So in this video, we're going to talk about how to solve a trig equation and find all of the angles when you have only one trig function or you have multiple trig functions that can be combined, or when you combine like terms. So in this case here, I have more than one sign, but it's going to be easy for me to include these on the same side of the equation. So if I rearrange these terms here, I bring the 3 sine theta to this side, I add 1 to that side, I'm going to get a negative 1, get a pen here, a negative 1 is equal to 2 sine theta. All right, if I divide both sides now by 2, really I'm going to have the sine of theta is equal to a negative 1/2. So what I want to think about here is that the sine of theta, the sine of some angle theta, is equal to a negative 1/2. So I have the unit circle over here just as a visual reference. Really, we should already know this at this point, but the sine of theta equals a negative 1/2 at 2 points on this unit circle, right? The sine of theta is a negative 1/2 here, and again right here. So what that means is that we're going to end up with 2 possible solutions here. So we have theta could be equal to 7 pi over 6, or theta is going to be equal to 11 pi over 6. Okay, but those are just the values that we see here in the unit circle. Really, if we had a function, or an angle rather, where it measured right here and our angle of rotation was this here, so if that was my theta at 7 pi over 6, we should also know that if we keep going another full rotation past that all the way around the unit circle again, so we've gone 2 pi radians past 7 pi over 6, we end up in the same spot, and the sine of theta is once again going to be a negative 1/2. So not only is 7 pi over 6 going to be a solution, but if I add 2 pi to 7 pi over 6, that's going to be a solution. So if I went around again now, all the way around the unit circle, once again 2 pi radians, that's again going to be a sine of theta is equal to a negative 1/2. So really what we end up with is not just theta equals 7 pi over 6, but theta equals 7 pi over 6 plus every time we go a full rotation. So that means what I'm going to write is that theta is equal to 7 pi over 6, and we traveled a full rotation every single time after that, so plus 2 pi, because that gives us a full rotation. But the problem is I don't know how many times I'm going to actually rotate. So I can rotate as few times or as many times as I want. As long as I go a full 2 pi radians, I'm going to end up right back at the same value. So I'm just going to call this n. So it's going to be 7 pi over 6 plus 2 pi n is one solution. My other solution from 11 pi over 6 is the same deal. So if we move this radius over here to 11 pi over 6, and we draw in our angle of rotation theta, which starts here and goes all the way around to there, that's 11 pi over 6 radians. But same thing, if we take this and we rotate all the way around again, we're right back to where we started at 11 pi over 6 radians. Okay, or 11 pi over 6 radians plus 2 pi radians. So here we're going to have theta is equal to 11, fix that real quick. Theta is equal to 11 pi over 6 radians plus, again, that full rotation of 2 pi, however many times we want to go around, n. So this is going to be the total number of solutions between, or for this equation right here. So it's really going to be an infinite number of solutions. Now, a lot of times a question will ask you to provide all the solutions between 0 and 2 pi. So I want theta to be greater than or equal to 0, but less than or equal to 2 pi. So if that's the case, well, now I'm only concerned with the numbers that I see here in the unit circle. So if this were my case, I want to solve the same equation, but I want to keep my solutions between 0 and 2 pi, well, now I'm going to have I don't have to worry about these extra rotations necessarily, because if I'm at 7 pi over 6, and I make a full rotation, I've gone more than 2 pi radians. So this would just be theta is equal to, my values would be 7 pi over 6 or 11 pi over 6. Okay, so it really depends on the question. If it's asking for all the values of theta, then you need to include something like this over here, where you have to say you have to account for all the additional possible rotations. Or if they're asking for all the values between 0 and 2 pi, then you just have to worry about limiting it to one rotation, to the unit circle itself. So I hope this video helps, and I'll see you in the next one.